Good morning, everyone. In today's video, I'm going to continue from where we stopped last time. And the last time I was just talking about how to divide the surface and generate points based on the provision of a U and a V value for it, which is the available of rows and columns for that surface. And in today's video, I'm going to build on what we have stopped, or where we stopped last time. And after you divide the surface, as you can see in the left image in Dynamo, as you can see how you can apply the adaptive component for box, and then how you randomize the height of the group for those AC or adaptive component element to make each one of them have a different randomized height value. So that's my basic target, is to give you this modification, customized node, how you can build it, and how you randomize the height of those adaptive component. And just to refresh your memory, that's where we stopped last time, to create a dividing surface by the number of U and V panel, which is technically the same as the quad panel you can download from the lunchbox. What also you really need as an input is this, the adaptive component itself. It's a very basic one, and it's just a generic model adaptive component based on the provision of 4 points. The 4 points will be generated into adaptive points, as you can see, and then you can connect them with the reference plane, extrude them, and then provide one height here parameter, which is definitely have to be a default. That means it's an instance parameter, so you can change that based on an individual element. You have to load that, of course, into the main Revit project environment, which I already did. Make sure, again, guys, that I keep repeating this. You make sure that the project environment is actually built on let's say metric system, and the unit of that metric system is just meter. So just hit an UN on your keyboard. All the time double check with this, and you have to see the metric is being set on meter. That's really important, guys. Anyway, so that's my surface. Probably going to see that in Dynamo as flipped. It's mirrored upside down, I know. So what I've done, I'll show you those if you are interested to generate them. It's just a different, little bit more complicated surface that we've done in the previous tutorial, which is a plain rectangle. In this one, it just goes for a 3 points curved. As you can see, that's the value for the first 1, 2, and 3. So that's the line. That's the first line. Those are the values for the second one. So this is this point, and then this is this guy here, and then this is this dude here. That's the value for them. There's another 3. That's the second ring. And then the third ring is at the end. This guy will not, I don't think you're going to see it. It's behind the curve here. This dude should be this one, and then this one should be here. Just list them all, and then just create a NURB curve by point to, I'm just turn them off because I don't need them. But if you want, just for the sake of demonstration, you see those, that's the 3 lines that generated the whole story out of it, as you can see. So those are the settings. You make a list.curve.create out of those 3 points, generating those 3 curves. If they are NURB curve, actually, then list them again into a list.create out of 3 items, and then give them the surface by loft. We've done that like a couple of thousand times now. So you got yourself a nice surface. This time is a little bit more complicated. As you can see in here, it's just disappeared. Anyway, it's a flip. That's what I wanted to show you, but unfortunately it's been disappeared anyway. So if I run this guy, I highly advise you to go and turn the the manual thing. I'm gonna run it, and that's the thing, that's the surface. Again, it's upside down in here. Now this dude technically needs to divide that surface by the amount of U and V. That's what we've designed last time, and now what we really need is to connect this guy here correctly. I just made a mess in here. So what we need is to connect the surface to the surface, and this dude have to be the U value. I designed to have this, I think, a full of a U. So now it will be 20, and then I will add a V out of 10, as you can see here, and I'll probably go really easy on my old machine here and make them 10 by 10. Let me go and see. That's what we designed last time. It's just a way to divide and to get ourselves nice points based on the U and V. So we have 10 rows and 10 columns out of this individual custom node that we design. And the beauty of it, it's have also the quad point set as the Lunchbox does, the quad panel customized node. Anyway, so now what I have to do is to get, the very basic advanced component by adaptive component by points. I've been explaining this all my previous tutorials. You can go back if you don't understand what I'm doing here. Anyway, this dude needs, in order to place the adaptive component, need a family type. And in the family type, of course, you have to put a family type selector, which I have, the node, the custom node. It's a generic adaptive component that I just show you in the beginning of this video. And it's also need a set of points, but those dudes or those points, it actually are quad points, not a normal flattened list, as you can see in here. So just connect this guy to this guy. Just remove that from the flatten, and that's a parameter. It's just to show you the inside available parameter of each one of those. Anyway, I'm going to run that, and then this node, or this really important node, actually have to distribute the adaptive component that I show you on each 4 point of those, as you can see here. And that's what we really want. The issue is they probably overlapping, I know, because that's a curvature and those go straight vertically, and they're all having the same height. So in order to create a complicated surface that have differences in height, we really need to add a randomize tool. I can show you in the next videos a couple of more complicated randomize that can do 2 elements or 3 elements. It depends on the list or the input list that you want to add to it. Anyway, so it's really good to have an element.parameter node to have a look of what you named the height. I just name it a height, and I know it's the default value for 1. That's basically what I need, and it's this guy listing for me all the elements of the adaptive component. I'm gonna need to flat them as I do here, and then that's the randomized thing. This guy will count for me how many I have in this list. So gonna get to me how many adaptive component I have. Let me cut that somewhere. So probably I'll cut it here. Wait, what is this? Okay, that comes from the list cycle. I'm gonna keep it. I'm gonna remove the flatten, just to cut it off to show you how it's actually working. So I'm gonna cut that, run. Let me show you what we are doing right now. This will just flat them. We get rid of the nesting that we have out of those sub lists. As you can see now, they are all as provided as a one list. It doesn't have a nesting list. That's really nice. Now I have 100, of course, because I have 10 by 10. So I have 100 box, 100 adaptive component. That's nice. And now on the other side, I have to decide the modification list. The modification list will be A to B, and then that have to be in a jump of a C. So A will be 0.5 meter. That's the minimum height for the adaptive component. The maximum height for the adaptive component, which is the end of this range, so it's from 0.5 to 2. That's have to be variable, and the interval is representing here C, which is the amount of jump. So it's actually going to create a list going from 0.5 to 2, jumping by 0.1, creating for us a 16 member in this guy. Now, really important to divide the 100 that you have on the 16. That's what I've done in here to get myself a 16 again, or whatever the number is. So that means that you need to cycle, or you need to repeat that 16 times So that's what you're going to do. Just you're going to list.cycle. You're going to get the actual list, which is this dude here, and which is, sorry, the actual list will be those guys, and you need to repeat them 16 times. So that's what I have done. That's my list in here. Come to the list. You have to repeat them by the division of the 100 over the 16. How much it is, I have no idea. And that will guarantee that this dude here will provide for us enough values to cover whatever we have in here, because we don't want that to be repeated in an incorrect way. And you need that to provide for me an actual enough amount of a variation to cover each one of those. Now just connect those guys again to a flatten. The flatten will goes to list.shuffle, so we can get rid out of this 0.5, 0.6. It's actually gonna make randomize for me. And let me just run that, and you're gonna see it's gonna take a seriously longer time, creating for us all the random value from 0.5 to 2, messed up, in a way that doesn't have the normal, any kind of, ordinary way, just like a randomized value to get in here. Now those, as you can see, we're giving as the value in here, it's an element.set parameter by name. That's what we have. And of course, the input for it will be the element themselves, which is the adaptive component. We get them here from the flat list, and sending them all the way to the element. The value is actually my shuffled list, which have like a million here value. And then the parameter here, this guy, what is the name of the parameter you want to change? Of course, I get that height. I know that because I designed the adaptive component, because if you don't, you just, this element.parameter will show you that this is the exact text. You need to be very careful with the caption, with the capital letter and small letter, and if there's any underscore, you have to exactly write it as it is here between two quotations, so it will be known as an integer for the software to be done or to work perfectly. So that's it, guys. That's how you can actually randomizing the whole thing. And like any node, any surface, next time you don't need to come and get into this hustle, an annoying process to do that. So what I'm gonna do, or the correct thing to be done actually, is to get rid of a group of unrequired repetition, and you open the Dynamo again. I already done that before. So I'm going to show you what I've done. I'm creating a custom node that each time you want to have a surface, and you already have a points for that, you just provide for it the list of a flatten object. That's the components list, flatten it, and then just send it to this node. You say I want the minimum height, I want to say the maximum height, and that's the slider controlling it. That's the intervals. I already have a default value for it. And the name of the height parameter, or whatever the parameter you want to check, just connect them, and it's gonna, I don't know how much we have as a U and V in here. Beautiful, 30 by 30. So we're gonna make a mess in here. No worries, it's gonna take like a couple of seconds. It depends on how fast your machine is. So the customized node is seriously important, guys, to be done and to be, excel in doing them, because they're gonna save you a serious amount of time each time you want to do, a surface randomizer, and that's, like it's a little make the overall script really long, and provide a wide range of opportunity to make lots of mistakes during the connection or during the creation. Just try to make the custom or the habit to create your custom node in a way that I show you in here, so you can be quick in your model and focus on creating new and more complicated geometries as you desire. And as you can see, that's what we got, and there is a serious amount of, as you can see, I think it's already been a big mess. It's been repeating the old. It's been repeating the old with the. I should have deleted. I should have deleted the elements that I have before I started. So I'm just gonna, wipe that out, delete, and I can just go ahead and make them 20 to make our life easier. As you can see, guys, again here, it's now perfectly done. I think we just needed to delete the old copies and before we go ahead and generate this one. So that's what I wanted to show you, that you have, you have your custom node here to get all the previous work instead. Before it was scattered and complicated to generate. Next time, just need to drop this one in here, and you will get this working very nice and very quick for you. Anyway, thank you very much, guys, for watching this. I wish that you get benefit out of this custom node that I just designed. If you have any questions or any comment, please leave that in the YouTube channel. I'll be happy to answer. Thank you very much and have a good day. Bye bye.